There you go.
Awesome.
Very good.
Thanks, Jerry.
All right.
Hi, everybody. Good to be here with you. I'm Jonathan Layton, but I go by Jomo because there's two Jonathans in our office, and I prefer my nickname. Only parents figured that out at the beginning. But excited to present with to you with Jeff Baker, who really was instrumental in getting this started, the calculator that we have. I'll got quite a few slides. We're starting late, so I might skip a few things. If I'm happy to stay after and chat or meet in person or online after on any of the things, including the people who are online today. So essentially what we want to introduce is how can we take the NFRC values that we have that are set to a specific size and use this to evaluate to the site specific sizing of a project, which is something that's been requested and now actually put into code with the 2018 BCBC update and the inclusion of the City of Vancouver Energy Modeling Guidelines. So I'll touch on that. I will tell you that I've talked to colleagues who are here in Ontario. They're being asked the same thing to give site-specific values. So this is not a BC only thing. We just happen to have it written in. And I've just had my first request from it from Alberta, and it's coming from cross-province architects who are like, well, I just want to know. Like, it's not a code thing, but I just want to know. So this is not a BC only. I think it's easy for us to maybe be the brunt of the jokes, but it's coming across Canada. So thought it's worth bringing it together on this. I'm going to learn this, where to point. Is there a secret?
Oh, Terry left.
Terry left. There we go. All right, real quick. So just about my company, myself. This is my dad, Mark Layton. Those that ever worked with him, great guy. Really, it's funny growing up. I was just like, oh, Windows, whatever, Dad. You know, I'd work the summer and be like, oh, I can't wait till I'm doing that. Then I went to school and I'm like, man, I actually kind of like Windows and engineering and stuff. And previous to my dad passing, I did an MBA. 4 months later, my dad passed away, and we figured out that we're gonna stay because the industry needs us. And so we've had some rebranding. We've become an NFRC simulation laboratory, so we help people in certification. We retain the right to consult. So before you send your stuff for certification, we can help you in some of your product design, and really trying to be a technical arm that a lot of the manufacturers need, because the technical expertise is the future. So yeah, we do a lot of stuff. We'd love to help you. Go ahead there, Jeff. So this map's a little old. I did this for a presentation for FenCan, and we were talking about energy analysis. And one of the common themes that I talked to people is they said, like, what do I have to hit? And what was kind of hilarious to us is we pulled up a map based on the energy code of compliance per province and the national building code and who's actually adopted to which national building code. And it was so funny to see that there was no uniform compliance. And in many ways, no one province was on the same pathway as others. So the overarching theme was, okay, NFRC, CSA standard, we're all on board with, but where are we going is a big question. This is, so we dug into some of the different codes, and there's different paths to code compliance that exist. Here's one from NECB. Essentially trade-off methods or performance metrics, or prescriptive, which was just like the labeled values. But each province was kind of headed in its own direction, which is kind of what brought us to this whole situation. I can't get this to work.
It'll work now.
It'll work now?
Should. Oh, you know what? No, it won't. You need to plug it in.
There we go. It is the end of the conference. End with a bang, right?
Okay, it should work now.
So this brings us to, like, what the heck happened in BC? Like, why was it so different? And what is it doing and impacting the whole industry? And what's the concept for moving forward? So just to give some, just recently, like hot off the presses in BC, for anybody who's wondering like where this is going. So our premier, he announced a few months ago that there was no, any town with more than 5,000 people cannot restrict single family lots to be single family. Meaning, based on the size of your lot, and that has yet to be determined in legislation, It could be a duplex or a triplex or a quad or even a townhouse. Like the developer or the municipality has the inability to restrict possible development that comes down because of provincial regulation. And then just last week announced minimum height requirements along of towers along the SkyTrain corridors and bus hubs. So I don't know the bus hub requirements, but what they have for SkyTrain corridors is if you're within 200 meters of a SkyTrain on either side, you have a tower that is 20-story minimum height. If you're within 200 to 400 meters, it's 12-story minimum height, and between 400 and 800 minimum is 8 stories. Yeah.
Wow.
So this has been put forward. It's not legislation yet, but there's political grounds to go for this because we need more places for people to live. It's going to take some time, but you better bet that they're going to say, I want my energy models to meet these requirements. And we're not talking part 9, we're talking part 3 towers. So anyways, so what happened in the 2018 building code is this line got added. Now, we already had this thing called the City of Vancouver Energy Modeling Guideline included in part 10 of the building code, but they added this one little line that said, in case of conflict between the provisions of the NECV and the City of Vancouver Energy Modeling Guideline, the provisions of the City of Vancouver Energy Modeling Guideline shall govern. So essentially made it the dictating document. Well, what we used to have was the City of Vancouver's VBBL, their own Path 10, Part 10 is energy, these different compliance paths. And the way that we approached it was very pragmatic. Path A, prescriptive, your labels, if everything's below the threshold model that they want, which went from 1.44 to 1.22, you just, if all your products have that on their labels, great. Build, have fun, there's nothing holding you back on the energy side. If you have labels and they don't, there's some product line that doesn't hit the minimum threshold, maximum threshold, the threshold, let's call that the threshold. You can do a weighted average. So you could say, hey, my sliding doors, they don't hit the minimum. I'm getting a 1.6 or whatever it is, but they're only 5% of the entire project. I'll do weighted average. Overall, everything gets below that. So I'll be fine. And then they had this Path C compliance, which separates in two things, but it's essentially the same, and it's a full analysis. So outfits such as mine, we would do using the NFRC policies and procedures, use therm and window, and change the sizes, and we would include coupler mullions, anything that needed to be included that was precise to that project would be included in this model. It was time consuming, it was expensive. You know, you can imagine on a tower with multiple different IGU units. I had to change IGUs, different configurations. Spandrel glass was in there, whatever it needed to be in order to fulfill that. But most of the time, we were kind of playing in this model on part 9 and also on some part 3 we could do. But this just became more and more kind of the expectation, which in my mind is what led to this. So this is all that is included in that quote unquote dictating document from the City of Vancouver Energy Modeling Guideline. This is just copy and pasted, Jeff, if I'm correct, from NFRC, the bottom section here, the thermal performance apparatus. But this is what really caused a lot of grief. It says the thermal transmittance for fenestration shall be based on the actual area of the windows and not the standard NFRC 100 size for the applicable product type. And it had more talking about area weight and model fenestration U values. But the way in this was interpreted, as well as this, is acceptable to simplify the catch-up by assuming the worst case by using the highest window U value for all fenestration specified on the project. Essentially, it's decided, hey, we're either going to take your worst window, and we're going to pick which one it is. So regardless of, because we're not going to use this NFRC size anymore. So see that tiny casement window there? That's now what you're getting for the entire project. Or we're totally going to disregard your NFRC labels. Cool, you have them. We don't care. Do an energy model for the whole thing. So a big headache right off the bat. And to be totally honest, in meeting with the province and City of Vancouver, I said, you got two problems here. One, your own energy guideline in the VBBL no longer applies to your own governing document, the City of Vancouver Energy Modeling Guideline. And two, we do not have the infrastructure in the industry in BC alone to satisfy the demands of this and keep construction, in time and at proper costs. So which brought us together to look at where we could go from here. Oh, and then there's this. So this is just a Part 9 home, but this was a unique case study that bleeds to this whole thing. So we also have the step code. I won't go into that today, but some of you know.
Yeah, please.
So yeah, I know. Real exciting. Yeah. So we had a project that we were asked to come in on, and they said, oh, we've previously done an energy analysis, and energy advisors come, and we've got windows quoted from Europe that can give us the values we want. We're being told we can't get those here. Here's a product line. Can you just confirm so we can move on with this project? So the original design, this is actually wrong. I've gone back in the paperwork. The actual original window to wall ratio was 41%. So they had this big overview, and they were convinced that they were going to get step 5. They were just going to solve the world's problems on this. And I went through the whole product line of what's available. And I said, you want a sub 1.0 U value, and it was 0.94 and 0.55 solar heat gain to solve your building model. I can't do that with a product, but I can run with this and try and analyze what I can get to. And this is just one iteration of what I did, but this was months of back and forth and like, can you manufacture this? And it's a wood window, like cut the depth a little deeper and you could fit it in there. There was no die that had to be created. And at the very end of it, they actually couldn't even get step 5. When I finally got a product line, they had to drop it down to step 4. And so it was just evident to me that, like, if we go down this route at the bidding stage, when you're supposed to provide all this information, and then at the construction phase, find out you can't hit what you're supposed to hit by this energy model, and marketing's been started, and everyone's all excited to announce this on a Part 9 building. Imagine what this has happened on a larger scale. And so there's a good gift we have here. So it just exponentially created so many models, time, the cost, and the potential for remanufacturing. Thankfully, it wasn't an issue for them, but you'd imagine with a lot of extruders, this could be a huge issue. And then just frankly, design time and just a single family home. So before I jump to the calculator, and I won't tell you this stuff because I actually have someone who was there. Jeff, if you could just kind of give us a little background on like what the purpose of NFRC started as and its usefulness to the industry.
So back in the late 80s, there was a lot of trouble with performance data being quoted on windows. And it led to a federal trade commission where some window companies were fined heavily. Some labs were shut down. It was a mess. So the federal government in the US got involved and came to some people involved in the industry and said, you fix it or we will. And that was the birth of NFRC. It took place, I didn't know the day, June 25th in 1989. I was in the room at that meeting as a young, naive grad student at the time, only about 15 years old. And that was the beginning of NFRC, and it's evolved over all these years to be the credible, what was the mantra? Fair, accurate, and credible rating is what it's been all these years. And it's the best data out there on fenestration. And if you weren't in the presentation, where was I yesterday? During the tech committee meeting, when I was reporting on CSA 440.2, they run completely parallel. So you get the same results out of both. So that's the history of where NFRC came from, why it exists in the US. And that is now, quick math, 34 years later. So it's been a long journey, but that's where we are today. But the need for something a little more than a rated label. Yeah. And for manufacturers, I'm going to say this right up front so you don't freak out, okay? We are not talking about changing the values on a label. We're talking about offering an alternative to supply additional information to building energy modelers. So rated values on labels, that is not even on the table, so that we're clear right up front. I figured I answered that question early.
Thanks, Jeff. Great. And I think the other thing to take from that is that line in the City of Vancouver Energy Modeling guideline that basically kind of allowed certain individuals to interpret like, well, I don't care about your NFRC modeling, is like you're throwing out oversight, you're throwing out, you know, certification, you're throwing out so many things that are actually of great value to our industry that allows us to but that's just some of the quotes. The government was like, if you don't do this, we're going to do it. And so yeah,
I know those guys.
yeah. So you throw out what we have as an apples to apples comparison to the like products. Like, how do you encourage an industry to move forward with metrics that change on every job? You couldn't. It's impossible. It speaks to the issue that we have with the metrics from other parts of the world compared to ours. So as Jeff said, they're harmonized. There is a Canadian supplement. We know that. But the one thing I want to get on is just that the thermal values are based on kind of 3 individual parts: the product type, the glass makeup, the IGU itself, and then the size. And when I try to explain NFRC to people of what that value is representing, this is essentially kind of a little diagram model that I represent. And it's just that center of glass value is a constant that exists. You're going to have that regardless of what your IGU is. That IGU will get the same center of glass, and your frame is dependent on actually, you know, the design. This is why we model them. And then there's this 2.5 inches that essentially is kind of muddied between the two. So highly conductive frame, your edge will perform, you know, obviously less than the center of glass, but it could perform in detrimental ways, I guess, to your overall value. So there really is a lot of connection between how your frame is performing and how it affects the edge. But also, to get those like comparisons, it has to be dependent on the size, because it's related to that ratio of glass to frame. So when you see a label, as I know we all have, this one is just a fake one that is online here, but it says a vinyl clad wood frame, double glazing, vertical slider. Vertical slider, we know that these values are based on all those different component pieces, the values from those components, and this size. And size really matters. And that's, I get why the cities are thinking about it. We did this is just a quick model we ran out where we just took a typical fixed window and we only changed the width of the frame. So a typical fixed window is right here is 1200 by 1500. And so we just manipulated it at 400, 600, 800. And you see you get a totally different value if your size changes. That's just how it works. So then it comes to, can we even use those values? Like, can we do something with it? Because there are limitations with NFRC. And I'll touch on these a little bit later, but modeling with NFRC, there's some things outside the scope. So combination frames, mullions and couplers, additional metal that's added to improve structural performance. So from an NFRC standpoint, if your product line, if within the actual frame itself or sash, it has a piece of reinforcement or a piece of insulation, that's a new product line. And
New option.
new option within the product line, but has its own CPD number. Yes. So have its own certified number. But if you have, you know, a coupler with a piece of metal, that is excluded outside that scope. And so there's like, how do we work on a full project when there are components that are going to be outside that scope? The other problem that I think Jeff and I can speak a lot on is there's no real, we call it a BS check with the therm program, meaning garbage in, garbage out. If you do not know what you're doing or do not know what you don't know because you haven't kept up with NFRC, you can model something and there's errors that it will provide you, but it's actually errors related to the software, not saying, hey, you shouldn't put a big hunk of, you know, steel here or whatnot. At the end of the day, when you import it in a window, it will give you a value at the end.
Yeah, I can give you an example of that. I've got clients that do their own modeling on design a new product, let's say, and they're working to hit a certain target, whether it's Energy Star code, doesn't matter. And they get it done and they're all happy they get it there. And I suggest they send it to me and let one of my simulators or myself take a look at it, evaluate it, and make sure it's consistent with all rules of NFRC. And I would say more than half the time, we go back and say, this part isn't right. And oh, by the way, it makes your number a little bit worse. And we'll work with you on trying to sort it out. But the fine detail, the last hour from 1 to 2, I sat on a meeting discussing how to model curtain wall for an hour. Okay. So there's fine details. This was just the simulators discussing that. And then we discussed if you change the installation, the glazing bead on a PVC window and it changes the gasket height by 1/8 of an inch, what do you do then? That took half an hour and they didn't get an answer. Okay. That's the level of detail the simulation gets down to and looks at the detail. That's important to understand.
Yeah. Yeah. So on some of that level, it's trying to give depth and to the NFRC CPD. And also, if you're doing stuff in-house, it's worth going to an accredited or a certified simulator and making sure that it is correct, because you can make a lot of assumptions that you're going. And that was one of the concerns with the full building analysis, because if everyone's doing it themselves, they could miss things and report things inaccurately. So just kind of summary on that, making sure that level of accuracy, NFRC's focus is on product certification, and implementing that schema that's dependent on NFRC 100, 200. And what I mean by that is the city of Vancouver is very clear saying, well, we don't want to replace NFRC. Like, you've proved it to us, we're not going to replace it. So use that, but then it needs to be used in a qualified manner. So Jeff, I'll turn this to you because you're the one who cracked the case here.
If you look at the upper left corner on the screen there, it says PF 97. That means 1997. I wrote this paper that long ago on a technique that when you don't have all the, like if you're working with your simulator, I've got all the information. I can give you any size you want when we're done with the NFRC model. It's done at a standard size. I can go into the window program, resize it to anything you want very accurately. But when you don't have all of that detail, and while all manufacturers have access to that detail, making it readily available is difficult. In this particular case, you're going to have center of glass properties and total window properties. That's all. Okay. So I'll know the U-value solar heat gain visible light transmission at center and total. With that, this paper goes into the details of how you break it down, calculate it. Now, that paper is about to be revised into a new white paper, hopefully in the next couple of weeks, to tweak the calculations with some newer data that we know now. But it showed you could get within 1% of the actual recalculated numbers. Well, with that technique, it would allow manufacturers with just limited sets of data on their products to give any size you want. You want me to keep going?
I can show it, whatever. Yeah.
So Jonathan and I've worked on a lot of data to take another deep dive into it, to look at this, to show how accurate this is. It looks really good. So the next step is NFRC. In the appendix of NFRC 100 right now, there's an example of calculating size-specific data in tabular form. Totally useless because you need a table for every glass option in your product. So it would take a lot of effort to produce that. This would give you a set of calculations that if all you knew is the center of glass and total product of one glass option, you can punch it into these calculations at any size you like and get a size-specific value. So that's where we're headed to develop this. There's lots of discussion on where it will get done, how it will get done. And FenCan is looking at possibly adding to their calculator online. NFRC, if we have time at the end, you'll get the bonus round. Yeah. I'd like to show you something on the NFRC website. We'll see if we can do that, where they might be able to add it to it so that you can pull up a label and then have a calculation under the label to get any size you want as a verification. But a lot of people are not aware of their label validator on the website. I'd just like to quickly show that as a bonus item at the end.
We'll rip through. So Jeff, where we got involved is, here.
Oh, did I screw you up?
Yeah.
Sorry. My mistake.
Going to Amazon already?
Yeah.
Christmas shopping here. All right. So Jeff, you had already taken some PVC casements, awnings. You had brought in the values from the standardized size, and then you just changed the the size is to say, okay, if I just change the size and I use all that information, what is my value going to be? And then you also actually modeled it to that size, correct? So you did a comparison between modeling it to the size using therm and window and then just using calculation. And as you can see, our kind of common difference within PVC was 1 to 2%, both smaller and larger than the standard sizes. And then we took it and this speaks to a little bit of the revision. I think these numbers will even tighten up a little more, but we did it on a curtain wall and a window wall product. The biggest discrepancy we're seeing is the smallest size. And what I believe this has been from, but it might be solved in the new iteration, is that it's so small that the edge of glass and the poor aluminum frame is actually being so negatively affecting the center of glass doesn't have enough room to offset it. But like, when's the last time you put in a project of a 300 by 900, curtain wall opening on the majority of the product? It's not going to happen. So the real error is consistently 1 to 2% difference when we just use the values and input it into a calculator. So where we got involved in was, how do we turn this into a deliverable that the client can then do on their own and then give it to the city how they like in a report format. And it really came down to, okay, we want to ensure that we're using the CPD because this is publicly verifiable. If you list this as saying, hey, this is where I'm basing my values off of, go look it up. Check if that's the window we're doing. We're not trying to skirt around. This is not more paperwork, flood work to try and get through our obstacle, which can happen in our industry. You can go check and make sure that it's valid. And so this is just, I want to break down the math of how that all works in the calculator. So essentially, as I said before, you see the 3 components. The NFRC window tool is really unique. Like when you draw something on therm, there's no depth to it. It just, like, the values go on forever. When you import those into window, it breaks it into these 45-degree angles and can tell you what the U factor solar heat gain is of each component and visual transmission of each component. So that is how the value works in the window program. And then the window program also provides what is your center of glass value. So this particular makeup gives me these values. This is known, it's going to go on forever, or to the size it is. And then this is what we're modeling, is the actual frame. And this is a screenshot of this frame in the therm program that gives us that U factor for the edge and the solar heat gain. So because we have the CPD, we don't have to model all these over and over again. Just the last part. When we import it into window, we set the size. So this is a default fixed window, and that gives us the value. So anyone who hasn't seen therm and window, that's what's going on in the background to get those total values. So we're looking at the knowns of what we have. We know what the standard size is based on the NFRC gateway sizes. And we also know from the CPD what the total U factor is, the total solar heat gain, and the total visual transmittance. Then from the drawings of a project, we can determine what the site-specific, what we call the weighted average width and height of each product type and glass type. And then we can also get those center of glass options for us. If our client doesn't have it, we can look it up on the window program and just match it to what they say that it is on the drawings. Some manufacturers already have that. Some glass suppliers may also have those numbers, but these are all knowns. These are all things, no matter what project, everybody has these. But we have to figure out these unknown variables in order to scale it. It's a scaling tool. So I have this here as the frame. What's the depth? Because if we know what the frame is accounting for, then we can base the 2.5 inches above from there. And then we know how much is just the center of glass, the U factor for each frame and the edge, and the solar heat gain of the entire profile. So I kind of broke it down in a visual way of seeing that. Going back to that U factor, you have that constant with a solar heat gain. The edge is kind of negatively affected here. or affected in some way based on your frame. And then your frame can kind of be all over based on your chambers and thermal breaks and thermal bridges. And then solar heat gain actually is a constant through both the center of glass and the frame, and is less affected by the frame, but it is. But what we have uniquely is this VT value, which is also reported. And this ends up being like our silver bullet, our little secret weapon, because the frame is zero. It affects it not at all. It's only the center of glass and the edge.
1 sec.
Yep.
Until one of you comes up with a translucent frame.
Okay.
Yeah.
Yeah.
Yeah. If you're thinking it. Yeah. Yeah.
Yeah.
Yeah. So just breaking this down by the math, essentially we know that if this is the set size of a fixed window, the visual transmittal will equal the visual total of glass if it's just glass. But it will be less because the frame is taking up some of that area. So we know if we have the center of glass value, of the VT, the visual total will be something that's less. So the reported CPD number will be less than the IGU values. And because we know that, it's now a known, we can determine the factor of frame, which allows us to calculate an average height of frame. And what I mean by average height is because we're working in this, square, rectangular, trapezoid, or whatever box. If you're a swing door that often has a more built up sill frame, what is that style? Yeah, that will be averaged out over the whole exterior perimeter. So it won't affect the overall calculation, but that's just something to know that it is an averaging out of that frame height. And because we now know that frame height, the average frame height, it actually allows us to back calculate, because we have that known, what the total of the U factor and edge will be. And because this is a known, and now this is a known, we essentially can scale it from then on. And as well as because we know the average frame height, we essentially solve this component because this is already a known. So overall, there are some potential source of inaccuracy. One is rounding errors, like the CPD only goes to 2 decimal places. So there are potential when you're rounding up, very small. The engineering side of me is like, everyone needs to know, but it's not going to be affected so to any extent. The other variation is that when you import, oh no, this is the frame height. And then when you import IGUs in therm, there's different heights that you set it to when you import it. And so basically on a curtain wall, it's 1900 on a picture, 1900 mils on a picture, it's 1400 mils. And so there's some slight variation there, but also not substantial to the overall calculations.
You got about 20 minutes.
Okay. So I just talking about how we did the modeling size specific. This is just a particular project that we did. We picked all the frame type, all the IGU information. We have this is the average width and height of each frame all together of this particular frame and this IGU. And then it is their percent. This is their total area and their percent total area. So the impact they have on the entire fenestration product line on that particular project to get it down to a single value. And so the input that we would have on our side, if someone gave me drawings, I would find their fixed frames or tilt and turns or vent, and I would just list their sizes. I have their window type. If they had like 50 of the same window, I just would change the quantity. And essentially I build out what is in order to generate it down to this single type frame or model. So here's a real project that we did, and I had to do an exact model for this. So we modeled all the couplers. We modeled everything that was unique to this to get a total value for this particular project. I I don't remember much about this other than the fact that this is a few hours that we spent into this. It was costly for the project. And again, it was a smaller project in order to complete this. But then I thought, okay, well, let's average out, let's use the old path B. Let's average out just the CPD numbers. Now, this was not a certified project, but I modeled it as if it was. So I ignored the couplers and all the things, I adjusted the frame. And I said, let's say that this is just a fixed window, just a tilt and turn, and we'll average out the CPDs and see what we get. And although the discrepancy is not huge because the sizes are not far from the standard size, it is inaccurate. So there's the variance between each job is going to be different based on how big the windows are.
Jonathan?
Yep.
Just to be clear, in this case, you're using the rated
Yes.
value and multiplying by the actual area.
Yes.
So you didn't recalculate.
I didn't recalculate
Yeah.
anything. Yes,
Be
thank
clear.
you. Yeah, so all I figured out was, okay, your area is, this is, man, I can't remember, but it's like, this is 60%, this is 5%, you know, down. And I just used the CPD number. You are correct, Jim.
Yeah.
But then I said, okay, let's use the calculator. Let's put it in. Let's build that same thing. We put all the window sizes in, and now we're using the CPD value, but we're using the math that's gone behind Jeff's thing. And this Jeff's paper, this was the value. This took me 15 minutes. This took me like 7 hours. So as you can imagine, the ability to do this on a manufacturer scale, the bidding, and be this accurate is huge. Here's just a breakdown of how it looks from what we've created so far. So like I said, these are just the rated values being averaged. Here's our center of glass information, the area. So we saw it was inaccurate at 1.13. And then I split it in two so you can hear, and here's the actual using the calculator. So we have a proof of concept. We know that it can work. I have some other examples that we can chat on a bit here. There are still some questions that we need buy-in from industry that we're working on. We had a great meeting this morning about what do we take next, but you know, what about couplers? What about reinforcing that's not covered within the frame? And it's unique from, I think, both my own experience, but especially Jeff's wealth of experience. We have assumptions of what is going to cause problems, but I think the biggest thing we know is we know that the NFRC actual standard way of modeling has some conservative nature in it. So we actually end up swallowing a lot of these problems by using the certified value in the first place. And that's the critical question that we've had with the province. We've had the province there, we've had energy advisors at these meetings, we've had Vancouver building bylaw officials, and they say, well, is this accurate? And we always come back with, what's accurate enough? Like, what are your energy models looking at for the wall or all the other components? So this is a critical question that we're working on as Fen Canada. I look forward to the presentation that carries that, because we want to go beyond this proof of concept. That said, I used a single family home before. Adrian, I do not remember how to pronounce this. Yeah, I know.
It's okay.
So we did an analysis for you, and this was at the awarded, you've already been awarded this job, correct? You've already fabricated all the windows, and you got a thing that said, give me your site-specific values. The energy modeler.
Yeah, wow.
So you did. It hurt, but it was great. Yeah, just to confirm what he said for people who couldn't necessarily hear, Adrian had two projects near the same time. One where they were told both after the awarding stage, we need a site-specific model, and one was say, oh yeah, we understand this is new, we'll have you pay for it. And the other said, too bad, this is in the BCBC 2018 City of Vancouver Energy Modeling Guideline with its very vagueness. This is what we want. We don't care. And I think on that project, it was like manufacture everything, apparently potentially $600,000 change if you didn't pass the requirement. Yeah.
Yeah, I have a question for Adrian. How do you pronounce the name of that
Yeah,
project?
that's what I was saying. Yeah.
10 minutes.
Okay. Well, welcome, Elchin. Yeah. So the presentation I was trying to get to Terry was a little bit of update, but I know what happened. I just can't show the visuals. So Adrian gave me his drawings, I had all the sizes. You sent me there's 4 CPD numbers on this because you had a laminated and non-laminated, both a fixed and a casement. I built it all and I modeled everything. And I got a 1.4, I think it was 2.2 is what we got when I modeled it. And then I ran it through the calculator and we got a 1.42. And I was like, man, that accuracy is awesome. Yeah. So it was nice to see that it works on this level. Now, one thing I do want to point out the calculator right now, we have it essentially to do one U value, one solar heat gain, one VT level for the entire project. But as we're seeing in the conversations come with solar heat gain, it's negatives and positives. We can break that calculator to be any elevation. I know we're on a project right now, second firm to come in that's got a bunch of townhomes, and the bedroom has this nice master bedroom, this nice big beautiful window that they chose to downgrade to get a higher solar heat gain. Knowingly chose to downgrade to get a higher solar heat gain. Now all the units that are oriented facing north, they're okay. But you better believe the ones that are on the west side that are got a big park there, they hated this last summer we just had. So there's real issues. So we can break this down, the calculator down by orientation. So we could say, here's your overall U value and solar heat gain per the south, north, east, and west, and actually give better information to the energy advisor in the first place and to the architects, and have them really think about what they're asking for in the design. Last one, I took a window wall project that we're working on, and I wanted to see, okay, I've already kind of saw that if I average the CPD values on their own and didn't use the calculator, there was some discrepancy, but really how much can I possibly get? And what made it really unique with this project is I had a lot of actual small fixed lights in it. And so in doing that, if you just averaged out the CPD number, the requirement for this job was 1.44. They got a 1.33. They passed. Woo! And I went through the calculator and it actually fails. And so, and I already suspected that, but it was interesting to bring this up and say, you need to make some adjustments now, because if this City of Vancouver Energy Modeling Guideline gets brought in the discussion, I have no way of helping you beyond this, because I know that it's going to fail. And this is more on our side. We help people with compliance reports. These are some reports that basically break down how the modeling goes in. And that's it. We'll take questions and answers there.
Well, but by the way, we checked on the name. It had no impact on the window performance.
Yeah, it was close.
Zero sightline or frameless awnings.
Yeah.
Operable windows. Obviously, the IGU is larger than the frame. How does the calculator does it calculate that as well? Does it account for that?
So when the frame is buried, is what you're saying?
Yeah, basically you have the IGU is what's visible and it's
Yeah.
larger, and the sash is structurally glazed on the interior.
Yeah.
So you got a larger surface area of glass than you
Sure.
do a framing.
Sure.
So your edge condition is, I don't know what you do with your edge condition.
There is a
I don't know how
Okay.
you get the rating for NFRC to begin with right now on,
Yeah.
on product like that. So there's lots of work to be done there. If we can get a rating and figure out how to, you could have a frame that's 10,000th of an inch high to account for the surrounding.
Yeah.
If we do that, it would need further testing.
Yeah.
I can't answer,
No.
but I think there's a possibility on tracking that as well. I don't see why it shouldn't work. Just the physics behind it.
Yeah. And as the calculator as it stands, it's reliant on the CPD. And that is going to be modeled according to the NFRC standards.
This is not a question, but as a member of the Education Committee, I want to call for a quick round of applause for this guy who did all the hard work to set up the education sessions for the last 2 days. And I can tell you it was a lot. So quick hand for Terry.
I love every minute of it. I truly did. Okay, for the bonus round.
Yeah.
Terry, I lost the screen. Okay, there we go. How do I get Jonathan's presentation off and over to a web browser? Can you do that?
Yeah, you bet.
Just want to share that screen. Yeah. Okay. So this is the NFRC website at cpd.nfrc.org. If you want to look something up, go into the search product directory. So on the right-hand side there, and see the bottom of the list, it says label verification. Go in there. So if you're looking at a label and you could see the full CPD number, it's got 5 parts to that number. Just for fun. Yeah. Type this in, LOW, because you guys are sitting over there. LOW-M, sorry, N is a Nancy, sorry, not, dash 25, dash 11057, dash 4 zeros and a 1. And then hit enter, or nope. Damn it, I hate their website for doing that. Start over. If you hit enter when you're in there, it never works. You got to click the button.
LOW
Dash N dash 25 dash 11075
075
dash 4 zeros and a 1.
2 3 4 1.
And then click underneath there.
Come on,
Damn, I hope this works.
looking.
Terry has a horrible internet connection. That's my story, and I'm sticking to it.
It's true. I can do
Because I did it on mine and it worked.
It's looking.
Normally, with a good internet connection, it just pops up. And what you get is a representation of the label.
Wow, I never knew that was there.
Okay. Now, for manufacturers in the room, if you have had your data updated somewhere along the way, it could show 3 or 4.
There it is.
So yeah, you get a representation of the label like that. But let's say something changed in a certification, middle of a certification cycle, and you updated the data, it will show multiple versions of the label. It's really good for you if the data changed in any way. Because if somebody's got an old label that's different than your new data, you have access to see it. Okay. So this is a powerful tool. It's only about year and a half old now, but I don't think enough people know that it's out there. So my hope with NFRC is on that same screen, you would get an option to type in size specific, and it would, because they have all the data you need to like 6 decimal places stored in the database. You could, if they put in a verification tool for size specific, comes up there, you type it in and you can verify the size specific. That's my hope, that would serve a really good role from NFRC if they just added to it right here. I'm hopeful of this because the calculations they need behind the scene are pretty simple to add into this. So I haven't talked to the gatekeeper of the CPD these days, but he's a good friend. So I'm hoping we can twist.
Obviously, you could get the values, but not a label, obviously.
Right. You would not get a label and it'll have a huge disclaimer underneath it, guaranteed. Okay. But I just wanted people to see that because I think that's an unknown feature on the website and can be very useful. And for manufacturers, if your data changed during a 5-year certification cycle on labels, they have a history of your labels there. So if somebody's got an old label saying it doesn't match your current data, you would have evidence to go back and find the old labels. And I couldn't find one that had multiple labels, but it does track something. I can't remember if it gives a time frame on those labels or not, but if you can find them, you can go to NFRC and get some help on those labels. So that's an important key feature for sure. So that was the bonus round.
Other questions? So as Jonathan mentioned, Fenestration Canada is working with a task group on this. Jeff and Jonathan obviously involved with a lot of other really sharp people. We're working with the city of Vancouver and the province of BC to revise the language that's in the energy modeling guidelines, looking for the answer to the question, how accurate is accurate enough, things like that. Our hope is that we get all of that done. We have the calculator to do this work very easily, and that they'll accept what that value is to be able to use in their modeling. We're also, we talked this morning, we're going to launch a research project that is going to look at mullions and reinforcing and couplers, et cetera, to see what those designs do to the performance values. So that's going to happen during 2024, I hope. We're working on it. Yeah, what we're hoping to do is host it on our website. So we're just trying to figure out the logistics of what that looks like and how it might work.
What's real important is to get the calculations as part of the standard. So there's a referenceable set of calculations. That's the big next step. There's a task group at NFRC that I chair to try and get those written, get them balloted in March. My real hope is things at NFRC move slowly most of the time. They tried to write it up and get it approved at the last meeting, but it wasn't complete. But it did spark a lot of conversation and a lot of people paying attention now. So I think we have a good shot at getting it approved at the March meeting of NFRC. I've committed to NFRC to have the white paper together in the next couple of weeks. And then the task group is going to review this white paper and the calculations, and then we'll get that into a ballot, get it into and hopefully get it right into the document. If they get it done and published, then we can run with it. And, theoretically, anybody that wants to could take those calculations then and program them in. Hey, you want to put them into your order entry system so that you can do size specific on quotes. It's the calculation if you've got the data set. That's the key and important thing. You need center of class and total. Well, whoever does your simulations has access to all that data. They could provide it to you in a spreadsheet. You could get it into a database. Those things would be possible because the push as the building energy calculations get pushed and pushed toward 2030 and net zero buildings, both commercial and residential, the performance calculations are going to be the way to get there in a cost-effective manner. The prescriptive approach in the code that I'm heavily involved in would get you there, but it will not be the most cost-effective way of getting there in a building. And so the need for this kind of information is going to become greater and greater.
We keep talking city of Vancouver, but it's coming everywhere. It's coming to a province near you.
Yes.
If I think the big thing is if you have any, I know it's easy to be flustered by the amount of technical hoops to jump through, but the information that comes out of NFRC is actually to our benefit. And if you like being involved at Fen Canada and being involved in the further development of that, because it gives a validation level that is not on your shoulders. So you're not being questioned by building officials or municipalities, but it can point directly to a system that exists. It's huge, but it really depends on how we embrace it. So yeah, it might need a shift in the industry and their mindset of it.
As manufacturers, you want any of these calculations being based on the data you've spent all the money on, that it has the validation support behind it. And if NFRC can develop the tool where anybody could go validate your number, as long as you follow the calculations and use the data, it should match what they put up on their website and give credibility to what you're doing. So I think that's got a huge, huge benefit. And I think that's what this group through FenCan and others getting involved in this trying to do is really important to get this done. My apologies. It could have been done 30 years ago, or at least 24.
Well, thank you for coming to the show. Great show this year. Really, really good. Thank you for participating in our learning lounge. It was excellent. We had great participation, full room for just about every session, which makes me feel like I'm doing something right. I'm providing some info that you guys are looking for. Certainly to all of our speakers and guests, they did just a phenomenal job this year. We're off to Montreal next year, so get that into your calendar whenever it is. I don't know the dates offhand. We're going to Kananaskis, Alberta for our AGM. Yeah, May the 28th to 31st. So that'll be really great. Be working on that soon. Thanks to everybody. Safe travels on your way out. Thanks to our sponsors. I don't have the list in front of me, but without sponsors, we wouldn't be here. So we're grateful to them. So a great time. Had lots of fun. Great dinner last night. Was good to see some people. Jeff got recognized for all of these years of effort and work that he's put in. We appreciate his time, of course. He keeps saying he's going to retire, but like Al, they keep coming back, which that's great for us. We'll take you as long as you can. Yeah, we'll take you as long as you can. So again, thank you from all the FenCan staff. Thanks to our members. Great show. Safe travels. Take care.